Так, мы снова в эфире, и следующий наш спикер — это Ondrej
So we're with
Mirtes.
you again, and
Это
our next
автор
speaker is
PHPStan, это
Ondrej
статический
Mirtes, is the
анализатор
author
для
of
PHP. И он нам
PHPStan, static
расскажет про
analyzer
дженерики
for
в PHP.
PHPStan, and he
Давайте
will talk
смотреть.
to us about generics in PHP. So let's have a
Thank you for watching my talk. I had to pre-record it because of difficult networking conditions, but I hope that it will make the talk better thanks to the magic of editing. So first, I would like to introduce myself. My name is Ondřej Mirtes, and I've been developing in PHP since 2005 on projects both big and small. But the reason why I'm talking to you today is because I like pointing out mistakes in other people's code so much that I created a static analyzer that focuses on finding bugs in your code without running it. Because since 2016, I've been developing and releasing open source software called PHPStan. And besides that, since 2014, I've also been working at Slevomat, which is a big Czech e-commerce website. But my eventual goal is to work on open source full-time. Before diving into generics, which is the main focus of this talk, I would like to spend a little while on introducing PHPStan in case you are not familiar with it. So I need to start by comparing compiled languages and interpreted languages. Compiled languages need to know type of every variable before the program runs. They won't let you run a program with an error like an undefined variable or calling an unknown method, because the compiler for the compiled language acts as the first line of defense before you are able to launch your application. But PHP is interpreted. If you make a mistake, the program will crash when the line of code with the mistake is executed. If the mistake is hidden in the third step of a checkout process, you will find out about it, or your customers will find out about it when they get into the third step of your checkout process. So PHP developers are spending a lot of time uncovering mistakes that wouldn't even compile in other languages, because PHP is interpreted and there's no compile step before we can run the application. So I was familiar with Java from attending the university, and when I started developing websites in PHP, I really missed the compiler from Java. But I realized that something similar could be created, so I wrote PHPStan. PHPStan is a static analyzer, which means that it analyzes code without running it. It gathers data about the code, it makes use of type hints and PHPDocs, and it tries to understand the code as best as possible. And it looks for errors, and some situations are pretty easy to spot, and other situations, especially in PHP, are more tricky. For example, some errors are not even crashing errors, they fail silently, but they usually represent a pretty serious bug. So, for example, in these situations, when the reference class does not exist, PHP doesn't even tell you about it, it just skips the code. So if you ask whether a variable is an instance of some class, or if you are catching an unknown exception, or if you are creating a string with a class name, PHP will happily create the class name for you, even if the class foo does not exist. But this is where PHPStan comes to shine, because it will tell you about these situations when you are referencing an unknown class. And there are dozens and dozens and maybe even hundreds of situations that PHPStan can detect like this. Most common ones that you probably stumble upon every day is when you are calling an undefined method on an object, or when you are passing wrong number of arguments or wrong types of arguments into methods and functions. So that was some basic information about PHPStan, and now we are ready to dive into generics. Generics is a pretty recently added feature to PHPStan, and the most simple explanation I can give you is that they are allowing us to generate an infinite number of signatures for a function. So imagine a function that returns the same type it receives in the parameter. So if it receives an integer, it will return an integer. If it receives a string, it will return a string. If it receives a float, it will return a float. Without generics, we have to use some white type hint like mixed. But mixed isn't telling the whole story. It's telling us that we are returning just mixed. It will not tell us anything more specific, like an integer for an integer or string for a string. So that's where generics are becoming useful. But unfortunately, I have to tell you that PHP itself doesn't support generics, and there was even an RFC about it, but it was dead since 2016. If we had generics in PHP, this is how they would look like for real. So they would be baked into the PHP syntax itself, and the language would support it in the core. But unfortunately, this isn't the situation today, and we have to simulate generics in PHPDocs. Fortunately, PHPStan is interpreting PHPDocs for the benefit of the user, so you can use generics as if they were in PHP itself, although you are writing them only in PHPDocs, but those PHPDocs are validated by the static analyzer, so it's fine. The basic building block of generics is something called a type variable. In PHPStan, you write it in PHPDoc in the add template tag, and you can use some short identifier like a single letter, or it might be longer, but you cannot use any name of an existing class as the identifier because it would conflict. You have to use something unique. Fortunately, single letters are not usually occupied by some existing class. So we define a template, and we can use the letter, the identifier in @parem and @return PHPDocs. We can also limit the type variable to a specific type. In this case, this function is only accepting objects of type exception, but it's still generating an infinite number of signatures, because, for example, if you pass in an invalid argument exception, it will also return the invalid argument exception. So if you pass in some subclass, it will tell the static analyzer that the function is also returning the same subclass. You can also reference and require a string with a class name and work with the resulting class. So for example, in this case, the find function is accepting an article class string with the word article, and it's letting PHPStan know that it will return an article object. The type variables can be combined into more complex types. So in this case, we are creating an array of these here. So this function will return all the entities of a certain type. Generic signatures can get quite out of hand, but after some practice, you'll be able to read them without any effort. So in this case, we have a function that has three type variables, k, v, and v2. First parameter is a callback that accepts a v and returns v2. Second parameter is an array with keys of type k and values of type v, and the whole function returns an array with keys of type k and values of type v2. So if you look at this signature for a little while, you will probably figure out that it's a signature for function array map that's built in to PHP. So even if it looks very complex at the first sight, you will be able to figure out after a bit what's actually going on. Until now, I talked only about type variables above functions, but we can put them about classes and interfaces too. So if we put add template above a class of an interface, we are then able to reference the type variable above methods and above properties without repeating the add template PHPDoc tag. And when a class declares a type variable, we can specify it when type hinting the class like this inside the less than and greater than operators. In this case, a collection of docs will not accept an argument of type cat, so PHPStan will correctly mark this as an error in your code. So yeah, those are the basics of generics. Before going any further, I would like to spend some time on type theory, which we're going to need a little bit later on. So covariance and contravariance are terms describing relationships between types. Covariance means that we are going from less specific type to a more specific type, from animal to dog in this case, in this chart. In contravariance, we are going in the other direction, so we are going from more specific type to a less specific type. The less specific type is usually or always implemented as an interface or a parent class, so animal can be either a parent class or it can be an interface implemented by doc. And there are certain rules connected to these terms. So when we are implementing or overriding a method, the parameter must have a contravariant type. It must be the same or less specific than the interface or the parent. We cannot go from a general doc to a more specific doc breed. So in this case, the booldoc feeder implementation is incorrect because the booldoc parameter type is covariant, it's not contravariant. So if we would try this implementation in practice, it would fail. So imagine a function that's called feedChihuahua, and it accepts a doc feeder. And there's nothing wrong about the implementation because the doc feeder is promising us that we can pass any doc in the feed method and the doc will be fed. But if we would call this function with a booldoc feeder, the implementation would fail because the booldoc type hint would not accept a chihuahua. So the booldoc feeder implementation is wrong and it's not actually possible in PHP. But if we make the parameter contravariant, if we make an animal feeder that implements a doc feeder, it's actually fine because the animal feeder can feed all the doc breeds and additionally all other animals too, so this is fine. On the other hand, return types work the other way. So the return type in the implemented overrider method must be the same or more specific. It must be covariant. So when we are returning a doc in the interface, we cannot return an animal in the implementation, because when we try to use a doc shelter, all the implementations should return something that barks. They should return a doc. But there's a risk that animal shelter contains other animals, for example cats, and cat doesn't bark, so the animal shelter implementation is incorrect. But if we honor return type covariance, we can implement a Chihuahua shelter that returns Chihuahua, which is a dog. It barks and additionally, I don't know, has small legs or something. So in this case, the covariant return type is fulfilled and the Chihuahua shelter implementation is correct. These rules are implemented in PHP itself. So previously, before PHP 7.4, the language supported only invariant types. So there would have to be the exact same implementation, the exact same type in all the implementations. So the Chihuahua shelter would have to have the same type, the same return type, dog, as the interface. It couldn't be more specific. But PHP 7.4 supports contravariance and covariance exactly as I was just talking about them. So the code that I showed to you is valid from 7.4 onwards. So we just established that these rules are useful, but sometimes they tie our hands too much. Imagine a consumer interface that accepts messages in some kind of a message queue, for example in RabbitMQ. And we have a specific implementation that we know that it will only ever receive a specific kind of message. But this goes against the parameter contravariance rule, because the type hinted sent by message is more specific than the message interface in the consumer interface, in the implemented interface. But generics is the thing that is going to save us here, because we can define a type variable above the interface and use it for the parameter type. And what's going to happen here is that when we implement the consumer interface, we can specify the type variable for the implemented interface using the PHPDoc @implements tag. And what's it actually going to do is that it will generate a variant of the interface that has hard-coded the send mail message type there. So the parameter contravariance actually isn't violated here. And if you are familiar with the Liskov substitution principle, it also satisfies this principle. So Barbara Liskov is also happy with this solution. So the generics can solve a problem like this for us. When we are implementing an interface, we are using the @implements PHPDoc tag, and when we are extending a class, we can use @extends PHPDoc tag. So if you are, for example, extending a general collection and you only want a specific kind of items in your child collection, you can say that this collection will only be a collection of docs using the @extends tag. And if you have a different situation, if you are extending a collection parent class and you still want to allow any kind of item in your child collection, you can preserve the genericness of the parent, repeating the same @template, the same type variable above the class, and use the type variable inside the collection type that's in the extends tag. So one problem that you will face with generics today is that PHPStorm does not yet understand them. If you would put the type variable t in the traditional @parem or @return PHPDoc tag, it would confuse PHPStorm because there isn't a class of such name, and PHPStorm would complain about this situation. Fortunately, you can use the traditional tags for something that an ID understands, like I did in this example, and then use prefix tags with @PHPStan dash for the specific syntax that the static analyzer can take advantage of. I have a few more examples that I will open in this playground. If you don't know about it, you can visit phpstan.org and you can write some PHP code here, and the playground will show you what kind of mistakes PHPStan will find on your PHP code. So you can kind of play with PHPStan on this playground with different settings. So in this example, we have a class hello world, and we have a method say hello, which accepts a class string of a type variable t, and the t is supposed to be an object because class string t where t isn't an object doesn't make much sense, and we are returning a t. The method body looks as simple as possible. It just instantiates the given class and crosses its fingers that the class actually doesn't have a constructor, because the arguments would be missing here. And PHPStan is complaining here that when we are calling the method with a mixed argument, which actually isn't telling us anything about the resulting type, and PHPStan is complaining that it's unable to resolve the template type t in call to method hello world say hello. And this means that PHPStan needs something more specific here, because it requires a class string, and the method is supposed to return a t, so it needs something more specific than mixed. Because if we were to save the resulting object in a variable here, say foo, it wouldn't know what the foo is if we only pass mixed here. If we pass something more specific, like an std class, PHPStan becomes happy with the result, because it will now know that $foo is a std class. But with mixed, it doesn't know anything more about the result, so it complains. Another example I have here is that I would like you to imagine that we have some kind of two interfaces that are interconnected. So I call them very explicitly, I call them original and derivative. And we have some kind of derivative repository or derivative retriever that accepts the original interface, and it's supposed to return a derivative. And then we have implementations. We have my original and my derivative. And the expectation is that when we pass my original to the getDerivative method, we should get the my derivative implementation. So my original and my derivative are connected this way. But PHPStan only sees that the getDerivative will return some kind of derivative implementation, and it doesn't see that my original and my derivative are interconnected, because we haven't told it yet. So right now PHPStan rightfully complains that this method is supposed to return my derivative, but only returns derivative, because there's actually no promise in the derivative retrieval interface that this thing will happen. But we can annotate our classes in such a way that PHPStan will understand what's actually going on, and it will enforce any interface implementation to actually behave this way. So what we need to do here is that we need to use a template, a type variable above the original interface, and we will require the type variable to be of type derivative. And we can say that the my original class implements original, and the original is connected to my derivative class. So right now they are connected in this way. And finally, the retriever interface will have a type variable t above the method, and it will type hint that it accepts original with the type variable, and the call will actually extract what's inside the t of the original and use it as a return type. So if we pass in original implementation that has the my derivative as the type variable, it will use it here in this place and return it. So PHPStan will now understand that when we pass in my original implementation into the getDerivative method, it will actually return my derivative implementation. If we try to break it to see if something happens, PHPStan will now complain that the method should return std class, but is actually returning my derivative. So it means that this connection of two interfaces through generics now works. In practice, you can usually connect some kind of event with an event handler in event sourcing systems, and there are many more examples where this kind of design pattern is useful. And the last example on the playground I have for you is when you encounter this error in the wild. So method say hello has parameter reflection with generic class reflection class, but does not specify its types. So this means that the reflection class, which is coming from PHP itself, has a type variable t, but here we are not saying what's the t supposed to be. So we are supposed to specify what the t is, and we can do it like this. We can tell PHPStan that the method only accepts reflection classes of type std class. And PHPStan is happy, or we can say that it's an exception. If you want to accept any kind of reflection class, if you don't want to limit it like this, you can use general object, or you can also make the method generic. So we can write template t of object here, and then we can use t here. And let's say that we will return the t of the reflection class. Yeah, we need to use object here. Yeah, and now PHPStan is complaining that we actually don't have the implementation. So, but it works. So, yeah, why the reflection class is generic when PHP does not have any concept of generics? It's because PHPStan itself contains so-called stubs that define generic type variables for built-in PHP classes and functions. And these stubs are in PHPStan sources in the stubs folder, and they annotate some useful specific classes from PHP itself with custom PHPDocs, and PHPStan then reads these PHPDocs and interprets them. So in this case, we have, for example, an SPL doubly linked list, and we know that this class is implementing an iterator and array access in the actual PHP implementation. So we can specify the type variable which the linked list will be about, and then we can say that when you put object of type SPL doubly linked list into for each, the for each will iterate over this type variable when we actually specify the type variable. And there are many classes from PHP itself annotated like this. Okay, so that was it about generics, and I have one more thing for you. At the beginning, I said that my goal is to work on open source full time because I love doing it. But unfortunately, it's not possible without having a business model. That's why I came up with the idea of PHPStan Pro, which is a paid add-on on top of open source PHPStan. And the open source part is always going to be free. It's a way to sponsor the development of open source software and actually get something extra in return. So you can try out PHPStan Pro by launching PHPStan and adding an extra -- pro flag after the analyze command. It will launch a web browser that shows you all the found errors in a nice user interface. Additionally, it continues to scan the codebase in the background, so if you keep it open, it will refresh automatically every time you save a modified file. And PHPStan Pro will also give you the option to fix certain errors and show you the effect of the fix on a codebase. It might be counterintuitive, but by fixing one error, you can actually cause other errors to show up. And it might be even a good thing, because you'll find more bugs that way. PHPStan Pro is priced €7 a month for individual users and €70 a month in total for teams. It's not a per seat pricing, it's a flat price of €70. You can also choose to pay yearly and get 12 months for the price of 10. There's also 30-day free trial period for everyone. So I hope you'll give it a try and send me some feedback. That's all from me today. Thank you very much for your attention. I'm looking forward to your questions that I will be answering in the chat. Thank you. Bye.